Okay, so this is the roadmap for machine learning and data science. See, why are we talking about mathematics? Why is it very important? There are a lot of definitions of machine learning linked with mathematics. If you see, if you want to learn machine learning, if you want to learn data science, you can see that the first and important step what you have to learn is mathematics. There are so many concepts of mathematics which are useful and which are required to understand the concepts in machine learning and data science. So if you observe here, the first and foremost step is this mathematics, right? You have to focus more on the mathematics. If you are strong at mathematics, then all your machine learning concepts, your algorithms, right, the libraries, everything becomes easy, even in deep learning. Okay, so this has to be very strong. That's why that is the beginning. If you are a new learner of machine learning, mathematics is the first step which you have to learn. You should not learn any ML algorithms. You should learn mathematics first. Okay, so rest all is general path. Once you complete mathematics, then you have to go for programming, maybe Python programming or R programming. Especially for data science, we use R programming, not Python. People always think that machine learning is and data science everything is Python, but Python is used for machine learning and R programming is very much suitable for data science. Okay, though both fall under same term, but still the programming language, there is a slight difference between Python and R programming. R programming is specifically designed for handling data or data related activities. So it has lot of features and functionalities which is more suitable for data science. Whereas machine learning, when you are implementing machine learning algorithms, you're writing an algorithm. It means you're writing a program. To program, Python is good. Programming using Python is good. Then you need to study about database, because we will come to the point. For all these, we need the heart of machine learning and data science is data. Without the data, nothing can work. So to store that data, we need to have a database. You should know at least few database tools for how do you effectively store the data and retrieve them. Then you may study the machine learning techniques, then libraries, ML libraries or Python. Python has lot of Python and R programming. Both of them have lot of libraries in it, inbuilt libraries. One of the reasons why Python machine learning has become very popular is because of its libraries. Yes, because Python has lot of inbuilt libraries. Using those libraries, you can make your job easy. For a simple example, I will say in a basic point, to write, to sort a given list of elements or to sort a given set of array elements in C or C++, I have to write lot of code, maybe at least 8-10 lines of code, where I write how do we sort the elements in ascending order or descending order. We have to write lot of code using some quick sort or merge sort technique. Whereas in Python, you have library which is called sort, which will directly sort in single line. You give using the library sort, using the function sort available in the Python library, you're doing it just 1 or 2 lines. Okay, that is the reason Python has become very popular for implementing machine learning, right? So we'll see how and why machine learning and mathematics are linked to each other. Then we have different ML algorithms. Then you go for deep learning. Data visualization is very important. Here, data visualization is part of data science. This is also a part of data science. Okay, so we do lot of visualization techniques in data science, and then you become an ML engineer or a data science engineer. We will have a session at the end of this workshop where we talk about different ML roles or data science roles and what is the difference between both these different roles. What is the difference if I become a data scientist, if I become an ML engineer, if I become an ML researcher, what are the different roles? We'll see. But the focus here is only on this machine learning, mathematics for machine learning, right? So this is the foundation, that is the starting point. If you want to learn machine learning or data science, this should be your first task that we are going to do it today. So in today's why mathematics for ML and data science, we'll see how mathematics is related to AI and the importance of maths in AI. Same things, similar things expressed in different ways. Topics to be covered in this course, and introduction to ML and data science, terms, terminology, and algorithms. Okay, this I am discussing this here because there is a point I would like to highlight here. There are different ways of learning mathematics or machine learning. One way, you learn the mathematics as a pure mathematician or from a mathematics perspective. Like you don't think anything about machine learning there or data science. You talk only about mathematics, like our mathematics subjects which we have been learning in our curriculum. So that is one way. But where is this applied? If you do not know that, maybe you might have studied the same linear algebra or calculus, but you do not know how and where it is applied in real time or in machine learning. Okay, so little of reverse engineering task I'm doing it here. I will explain the importance of mathematics to you. Then I will give an overview of the terms, ML and data science terminology which are used, because while teaching every concept of mathematics, I'll be telling you where is this concept of mathematics is used in machine learning. Okay, so when I'm teaching you eigenmatrix or determinant of a matrix or matrix decomposition, I will tell you where it is used in machine learning. So when I say decomposition is used in dimensionality reduction or in image processing, if I say that, or in PCA, if you say that, you should know what is dimensionality reduction, you should know what is PCA. Without knowing that, maybe you're confused. If you are aware of ML algorithm, that's fine. This will be easy learning. Somebody who ML is a new thing, right? So to avoid that, in simple terms, in simple language, without using any technical term, I'll be explaining you some terminology of ML, like what is regression, what is logistic regression, what is clustering, what is KNN algorithm, right? All these things will be discussed in brief without any technical knowledge, because I am introducing this here itself as a machine learning subject, because while explaining, I will be using those terms frequently to add value to my course. When I'm teaching matrices, you will say, sir, I have already studied hundreds of times this matrices, but why and where it is used. For that, I will be explaining with examples where it is used in machine learning. So for this, I will be introducing some terminology of ML and data science today. Please mute.
मैम अभी नीचे कुछ भी नहीं
तब आपने फोन किया ना तब वो मीटिंग
Can you please mute at your end? Yeah, thank you. Right. So little about machine learning, because we are talking, I'll be talking more about a mathematics perspective only. I see machine learning as mathematics. I say definition of machine learning is mathematics. Okay, we'll see different things. So generally, ML is all about designing algorithms that can automatically extract values from the data. Okay, it should extract me valuable information from the data, right? See the word automatically. It should do it automatically from the data. This is one definition, simple understanding about that. So given a historical data, best example, given a historical data, I should design some algorithm which should give me some insights about the data. It should do it automatically. So the focus is on automatic. That's why we are talking how to automate things by writing programs or by writing algorithms. That's where ML comes into picture. You have data has been existing since many years. We have data, we have mathematical concepts. Nothing is new in machine learning. Just an extension or a combination of multiple concepts of computer science subjects. Maybe mathematics or statistics, probability, or some computer science algorithm like sorting, searching, all this combined together forms this machine learning. Okay, so there are three core concepts of machine learning. One is data, second one is model, and third one is learning. You should know this because these are very frequent terms. I have just included one slide about introduction to machine learning. So what is data and model and the learning? So without data, you cannot do anything in machine learning. It's the core of machine learning. Data is required because machines are being trained, they're learning from the data. They're given a data, my whatever instructions I'm writing a code, I'm writing some algorithm. This algorithm is taking the input, the data is taken, and the algorithm I am taken, it is giving me the model, right? So data is the core. The main goal here is to design general purpose methodologies. So maybe if I say I have 10 years of rainfall data in the state of Tamil Nadu, for example. So coming year 2025, what will be the rainfall? I have to do prediction, right? Or I have to design such a model that using this data of Tamil Nadu or using general data, I should design a model which should be able to predict the rainfall percentage in any given state of India. So general purpose methodologies, our focus is on that, right? Now to achieve that, we have to design some model. So I'll come to this model part. Let's see learning first and then come. Learning can be understood as a learning way to automatically find patterns and structure in the data. It means when you have historical data with you, you have to identify some patterns in that data. Identifying such pattern itself is the model. Expressing it as a numerical, mathematical equation. Okay, so when you talk about machine learning, we talk about three terms: data, the model, and the learning. Okay, data which is required, which is core. Without data, you cannot form any machine learning model. Model is kind of a mathematical function. It's a mathematical function, I say. Any machine learning algorithm, any model you design is a mathematical function. Okay, and the learning is understanding the data, trying to identify different patterns in the data, identifying some sequences or structures in the data. Machine learning and math, the relation between both of them, how ML and mathematics are linked to each other, that we'll try to see here. So that's what I said. No, one of the reason ML has become popular because of its libraries and frameworks. ML is very popular because of its libraries. It has a lot of functions which can make our job very, very easy. This is fine. Libraries are there, frameworks are there, that's okay. But why we need that? To become a professional in this field, you should know the logic behind those libraries and frameworks. That's what I was saying. During placements or during interviews, no, they ask you to explain how is that particular model or algorithm or library or the framework is written. So you have to explain them mathematically. Why? Because when you become a ML researcher or a data scientist or a similar kind of a job related to machine learning, your job is, see, what is the work being done in machine learning? Already ML algorithms are there. Why the world is running behind ML again? What is there in that? We are trying to propose new algorithms. We are trying to advance the existing algorithms, overcome the drawbacks of the existing algorithms, so that we provide the best ML models for doing any job. Maybe I'm doing prediction, classification, I want to do it perfectly. Okay, so when you are working in such kind of an environment, you should know how is that principal component analysis done, what is underlying logic, that is required to know. That's why that's what we are going to learn in this course. So in this no mathematics, we have to, sometimes we need to write the code from scratch. You have to write a programming line for calculating determinant of a matrix, then write a programming line for calculating eigenvector, then for eigen value. So we have to do lot of we have to write lot of programming there. So you should know how is that calculated, then only you can program. That's why at our SC programming course at NIT Trichy, we say that we try to solve only mathematical problems in programming. Even in the IIT Madras, that 3 years BSc degree, they are having a course on programming where they are teaching mathematical techniques first in programming subject, asking them to solve those mathematical problems using C programming or any programming language, right? It is very important. It also helps in debugging the ML algorithms. So different definitions. One very important and one of the favorite definitions is that machine learning model is a type of mathematical model. It's a mathematical model. Okay, after being trained on a given data set to make any predictions or classifications, but it's a mathematical model. Okay, you know the best thing, you might have seen some examples of regression. In regression, how it's a simple linear regression, we have y equal to 10x plus 3.4, such kind of this is a linear regression model. Or I may have 2x1 minus 3x2 plus 5.092. This is a regression model or a machine learning model, because regression is one of the techniques in machine learning. This is not new, it has been there since ages, right? But we are trying to combine those mathematical concepts and forming a course called machine learning. So I would say machine learning is just an extension of mathematics. Mathematics plus little computer science added becomes machine learning. That is why we are focusing on learning mathematics for machine learning and data science. Mathematics is heart of machine learning. Normal thing. See, machine learning equal to mathematics. There is nothing new. It's all mathematics. You take clustering, you take probability. Probabilistic models are there in machine learning. We use probability there, right? We do hypothesis testing using statistics. Statistics was there before machine learning also, since ages. It is there. So nothing is new in that. Again, this is one more definition of machine learning. It's a field that intersects statistics, probability, computer science, and algorithms. This is what I was talking about, right? Machine learning is nothing but a combination of different courses which you have already studied, like probability, statistics, linear algebra, calculus, some computer science algorithmic subjects or programming subjects. Why? You need to write code, you should know programming. You need to write algorithms, you should know algorithm design techniques, so that you write better algorithms. Okay, so this is about the different definitions, or this also talks about why mathematics is required for machine learning. So machine learning is nothing but an extension. Mathematics plus extension of some computer science courses will give you machine learning. Okay, so that's why we are focusing on the mathematics part, which is required for this machine learning much. So yes, one one important diagram which talks about the 4 important pillars for machine learning and the foundations required. If you see, machine learning has lot of techniques. In general, we have these 4 techniques. We do regression analysis, we do dimensionality reduction. Again, I said these terms are new for some of them. I will be explaining them in simple terms in the second half of this session after a break. Okay, so don't get confused by saying no, because I may be jumping into these terms. I'm simply saying machine learning has 4 pillars. That is regression. What is regression? What is its use? Right? What are the applications of it? That we'll see. We'll try to understand them, not technically, but in simple terms. So this is just to focus on the foundations. Actually, I want to focus more on the foundations. But before that, we should know what are the 4 main pillars of machine learning. So machine learning has different algorithms. Lot of algorithms exist in machine learning, broadly categorized into 4. One is regression, second is dimensionality reduction, density estimation, and classification. Okay, maybe a lot more things we have. We talk about deep learning, we talk about data science, right? We talk about transfer learning. Lot of things are there, but still basically 4 things in machine learning. Okay, so in regression analysis, we know we have different terms like linear regression, lasso regression, logistic regression. We talk about different things. All those come under this umbrella term regression. So generally, there are 4 pillars for machine learning, that is regression. Now, to understand all these 4 pillars, to study all these 4 pillars, we have to study about different foundations of mathematics. So what are those foundations or the base which are required from mathematics, which are useful in understanding the machine learning? If you see, first linear algebra, vector calculus, analytic geometry, probability and distributions, optimization, and matrix decomposition. These are only a few, but again, they have been highlighted here as broad categories. I will explain you how these mathematical techniques are linked with these four broad pillars of machine learning. Okay, in next slides we'll see that. So this general talks, if you see, this is very clear from this that you need to know mathematical concepts. Is there anything new for you? Nothing. You studied algebra already, you studied vector calculus already, you studied probability and distributions in your school or your +2 or in graduation, analytic geometry which you have been playing always. Optimization also, some engineering courses have this subject optimization, and matrix decomposition may be a new. So little concepts are there but here this is talking only about machine learning. For data science, only one more, along with these concepts we need statistics. We need everything, we need all these things for data science as well, but along we need statistics for data science specially. Okay, so this is what our focus on. We will be studying again. It will be I know a typical statement to say that nothing new. You are just revising what you have studied before, I would say. Okay, so it's kind of a revision you are doing, or maybe you are learning some courses, some topics like optimization, decomposition, little about statistics if you have not studied before. There are some advanced testing techniques like A by B testing, which is new, which has evolved after machine learning has come into picture from statistics. That way, we have definitely, this course is useful for you for revising some existing concepts of algebra, calculus, probability, and learning some new concepts like optimization, decomposition, and statistics. So in this course, we'll be learning these around 8-9 concepts: linear algebra, matrix decompositions, vector calculus, probability and its distributions like Bernoulli distribution, Gaussian distribution, binomial distribution, and so on. Okay, then optimization, statistics, regression analysis. This is new, not new, but in a different style. Mathematical metrics. Yeah, one highlight I would say for our course is about this mathematical metrics used in ML and DS. We are going to have one session or almost two sessions on the metrics used. Okay, there are a lot of activation functions like sigmoid, Adam optimizer, right? And we have a lot of different optimization activation functions. Okay, so those metrics like mean square error, MSE, log loss function, all those mathematical stuff which you see in ML and deep learning algorithms are also covered in our course, right? Again, ultimately Python implementation, which makes your ML implementation easy. Yeah, this is one very important slide. So from here we are going to see why we need these concepts of mathematics. Okay, so yes, why only these concepts? Because you may ask, sir, there are a lot of concepts in mathematics, but why only a few particular concepts are picked up for machine learning? One question, or a different way, if I ask you, how are these mathematical concepts like algebra and calculus are used in the ML techniques? How are these ML mathematical techniques are used in machine learning? Okay, so that's one we'll try to see. Just a second. Yes, so this is one important point you should understand, why only these concepts of mathematics, or maybe you may get an answer from this slide that how mathematics is used, how it is used in ML directly. Okay, So I'll talk little about data here, little about machine learning. We say you should have a data with you. When you have data, you try to do fine tuning of data. Again, this is a new term for new people. Fine tuning means just preparing, cleansing the data, preparing a proper data into proper structure. So you have the data with you, you fine tune the data, you convert into numerical form. That's it. When numbers have come, mathematics comes into picture. Okay. So when you have the data with you, raw, unstructured data, fine tuning actually converts that into structured data, removing some missed values, all those things. I'll talk about these things when we talk about data science. Okay. So because data science is talking about this data, now we will focus on ML part, then we'll go back to data science. So convert it to structured data, proper format, in a neat, clean format. Then we convert that data into numerical form. That's it. We have numbers everywhere. We have numbers. How can we convert to numerical form? Best example, simple examples. Suppose I am having gender in my data set, male and female. So we can give some numbering 1, 0 or 0, 1. So this male and female are text data or string data. They are converted into numerical data here. So you have a number now. For example, you have a data set, something like this. I have the maybe name of a student. I have roll number. I have his gender. I have its course. 4. So I have some A, B, C. 1 roll number, 2, 3. Gender may be male, female, and male. Course is CS, mechanical, ME, or civil engineering, for example. Right? This is numerical already. Name I don't need, I can eliminate because I have one unique entity, that is number. I said no, you can convert this field to numerical field by putting ones and zeros. This is converted to numerical. You can have a mapping, you can still have a mapping for this. CS as a number, ME as another number. You can give some mapping to that. You can use some mappings like 2 or 10, 20 or 30. That way you can convert that into mappings. If overall, if you observe, when you have a data, you are using data science concepts, you are trying to convert that completely into matrix form. Sorry, not matrix, into numerical form. Okay, numerical form. Right. Let's try to understand how this is required. Knowing that for machine learning and data science, we need data. Assume that we need data for everything. If this you know, let's see how these mathematical concepts are linked to this machine learning. Okay, so machine learning data is converted to numerical form. We represent numerical form of data as vectors. See, I have the roll numbers of students. I like this. It is forming as a vector. We'll see that in detail. We'll see what is a vector, what is a scalar data, what is a matrix in detail. But now to understand how these mathematical concepts are linked to machine learning, I am explaining you. So roll number is a vector. This is a vector, right? You know about vectors, one dimensional vector. So you have vector here, or you take gender field. You may have vector like this 1, 0, 1, 0, 1, 1. You have a vector, right? So that machine learning data, the input data is converted to numerical form. We represent numerical data as vectors. Table of such vectors forms a matrix. Table of such vectors. One definition of matrix is combination of multiple vectors. Okay, so combination of multiple vectors forms the matrix, right? So when you talk about, when you have the data converted to numerical form forms a vector forms a matrix. That's where we study about linear algebra. The study of vectors and matrices is called linear algebra. Now you understood how and where this linear algebra is used. When you have the data for your machine learning algorithm, you should know linear algebra, because you're converting that data into vector and into matrix. Then you're performing matrix operations. You're doing matrix decomposition, you're finding matrix inverse, you are finding matrix determinant, you are calculating eigenvalues of a matrix, eigenvectors of eigenvalue, lot of things you are doing with that matrix. How is the matrix formed? From the machine learning data. And why we need data? Machine learning is nothing without data. We need data for machine learning algorithms. I hope you understood now why are we studying linear algebra in the subject of machine learning. Right? Next. You see, given two vectors now, assume there are two vectors, given two different vectors representing two objects in real world. In the same, again, we have a data set with us. In that data set, we have a lot of data. Each column can be a vector. When given two vectors which represent two objects in real world, okay, we want to make statements about the similarity. I have two vectors with me. What is a vector? Collection of numerical data. What is the data? It's a machine learning data. Okay, so I will not talk about again vectors again now. From here onwards, I will talk about vector directly, which is nothing but a machine learning data. So you have the two vectors in a given large data set. You want to find out how similar they are. Why you want to find out how similar these two vectors are? Because we expect that when there are two similar vectors, the idea is that vectors that are similar should be predicted to have similar outputs by the ML algorithms. I have two vectors v1 and v2. If they are similar to each other, I form a machine learning model. I design a machine learning model. I give v1 as input to this model. I get some output. I get some output O1. If I give v2 as input, I get some output O2. Right? So it is expected that when these two vectors are similar, we expect to have similar outputs. So when two vectors are similar, I will try to remove this vector v2 from the data. Why I have to remove? That's what. There is a concept called curse of dimensionality. Because the data set what we are having today is of huge size, very big size of data we have with us. When you have such huge size of data with you, you cannot apply all your mathematical techniques on those data. Sometimes there is irrelevant information which is not useful for your machine learning model. If I take student data from our university at NIT Trichy, if I take the student data from the administration, they may give me the name, roll number, the subjects chosen, your parents' name, your date of birth, your academic performance, your address, lot of things, your hostel room number, your block number, lot of information. But if I want to judge about your performance in academics, I don't need all those information. I need only few particular parameters from it, right? So we need to remove those extra or irrelevant fields from the data, form a better data, or in our term, I will say form a better matrix or a smaller important matrix, which has the strong relationship with the actual data. I don't need your hostel number to know about your academic performance, right? So we try to eradicate some of the data. Sometimes I don't need marks of your other subjects which are not related to computer science. Sometimes you do electrical course, sometimes you do mechanical course. Those things are not required for us. In finding out, in making some judgments that whether the student is eligible to get a computer science or a software job or not. So maybe I'm analyzing your academic performance. I have to remove those things. So a lot of things we do there. For that, we need analytical geometry, which helps us in finding out the similarity and the distances between different vectors. Dot product, no, you know about dot product, cross product of vectors. We do all those operations and we learn those things from analytical geometry. So I hope you understood now. When you have a machine learning data with you, which is represented as vectors or a matrix, I want to find out relation between two or multiple vectors to make my job easy, or to make to have a better model, or to have a fine-tuned data, removing irrelevant data. Sometimes not all the informations are required to make some insight. I have to delete some columns from the matrix. from the data set, I mean to say. So which one to delete? That you can find out using these concepts in analytical geometry. So we study about analytical geometry also in the course of machine learning. Next. Yeah, this was I was talking about. Data is very large. When data is very large, the dimension of the matrix will be very large. Because why I am talking about matrix about data? I say data is written as numerical form. That numerical form is represented as vectors. Vectors form matrices. Indirectly, your input data set is converted to a matrix form using some library of Python programming. That matrix I am taking as input and I am applying my machine learning algorithms. I hope you understood now. Or blindly you can see for now, until we go into deep learning concepts, for now you may assume that the data set what is there with you for applying ML techniques is nothing but a matrix. So when the data set is large, your matrix size will be large. When the matrix size is large, finding out rank of a matrix, finding out determinant of a matrix, finding out eigenvalue of a matrix becomes challenging. We cannot. We can do it. Programming can do it, but there are some limitations yet in those programming. Therefore, we talk about concept called matrix decompositions. Okay, because applying the available matrix operations might not be possible on higher dimensional data. Inverse of a matrix, you can find it out, but up to what extent can you find out? If the matrix size is 1000 cross 1000, if you are doing it manually, assume how much time it takes, right? So for that reason, we have a concept called matrix decomposition, where we try to reduce the size of the matrix. One best example I will give, which we are going to study in this course also, is the Cholesky decomposition. We have something called Cholesky decomposition. It's a mathematics technique. This is a mathematics technique. People who do higher education in mathematics might be learning this if you have not learned this in your graduation or post-graduation. What is this Cholesky decomposition? What it does is, assume you have a 3 by 3 matrix. Okay, this Cholesky decomposition technique will convert the 3 by 3 matrix into a upper triangular matrix or a lower triangular matrix. Okay, why I'll just see here. You have a matrix with you, a 3 cross 3 matrix. Simple example I'm taking. If I convert this into a upper triangular matrix, something like this. Okay, again, this is a small matrix we're talking about, but when we see large matrices, it becomes very easy. Number of zeros is very less here, but if you take some 20 cross 20, you have only few numbers, 50% or more than around 50% are numbers, remaining all are zeros. By converting this matrix into a upper triangle or a lower triangular matrix, it is very easy for me to draw insights. What kind of insights can I draw? If you ask me, what kind of insights? See, the product of these three, okay, the product of these three is nothing but the product of eigenvalues. Or kind of, we have a lot of rules, we have a lot of principles like that. So here I have to do a lot of operations, but here diagonal elements, just do that. Okay, so there are a lot of advantages with this. We'll see when we study about decompositions, how it is used in machine learning. But I think you can easily observe the number of operations which I have to do on the numbers is reduced here. When I transform a given matrix in a 3 by 3 into a upper triangular or lower triangular, by not losing the features. What is this matrix? This matrix is from the data. The data given for us to apply ML technique. So it is nothing but feature. Again, I use the word feature. Let me introduce it here. When you have a data set with you as a matrix, the column C1, C2, C3, in machine learning, we say they are features. Features. So without losing the features, whatever knowledge this matrix was giving to us before, the same knowledge, the same insight, this should also give to us without losing its feature information. Because when you are reducing its size, It should not lose its property. It should hold. Okay, so this is one beautiful concept which is really and widely used even today in machine learning and deep learning research. People doing research using machine learning, they use matrix decompositions techniques to reduce the size little, again, just to make it interesting. Mm, I don't know, but this is maybe this at this point of time it is wrong to say this. Nobody is talking about machine learning. They say machine learning has completely been dominated with image processing or computer vision. It has been completely dominated with these things. Anybody you touch who talks about machine learning, they talk about image processing, identifying the facial emotion, identifying the mask person, whether it is the same person with mask or without mask, right? Identifying whether the plant is having some disease or not. Lot of applications. So I see, with my knowledge here at NIT Trichy, I see 95% of people talking about only these two concepts when it comes to machine learning. Sometimes I get confused or surprised to know, is it machine learning course or is it an image processing course? Because everything they do with this only. Why I said this? Because when you have an image, which is nothing but set of pixels, right? Pixels, you when you purchase a camera mobile, you see pixels. Each pixel is a dot. It is nothing but a 3 by 3 matrix. It can be represented as a 3 by 3 matrix with zeros and ones, like this, something like this. Each dot in that image is formed with lakhs of pixels, and each pixel can be represented as a matrix, 3 by 3 matrix. So now assume you have a small, maybe I will take a small image which has only 4 pixels for assume. Assume a small image which has only 4 pixels. If I convert that to a matrix, it becomes what size? 3, 3, 3, 3. It becomes 6 cross 6, right? 3 here and 3 here, this way. It becomes 6 cross 6 matrix. Okay, so this is okay. But is it image with 4 pixels? No. If it is with 16 pixels, assume it's 16 pixels. So this increases multiple folds. So the size of the matrix which is representing that image is becoming very large. Now you want to do some, you want to find out some insights. Maybe you are brightening the image taken in the dark. This is one application. You are given a dark photo, you are asked to brighten that image. You might be using a lot of apps like Snap or maybe some Snapseed. So many apps available which can brighten, lower your brightness of the image, morning, shade, dark, black and white. Lot of things you do. That is being done by just modifying these zeros and ones. You have to transform the values to zeros and ones. How do you do that? Suppose if I find sum of this, one simple technique here. If I find sum of this matrix, 0 plus 1 plus 0, if I add, it is 4. It means this pixel value is 4. The another pixel value is 8. Another pixel value is 6. Another pixel is 4. Another is 8. Another is 4. Something 3 and 1. Simple technique. So by this, if I observe, see, which are more contrast, which are light, dark and bright. If you say 8 means it is more darker in color. 1 means it is light. When I have to enhance the image, increase the brightness, maybe I have to increase this 1 to 3. That is what is happening underlying in image processing. At a basic level, I'm explaining to you. So you see, image, then pixel, then matrix, and then matrix operations. But you have large images, you have to apply matrix decomposition techniques. Okay, this will help you to do, again, linear algebra concept, matrix decomposition will help you to play with lot of image processing stuff. So I hope you got an idea how mathematics is linked with machine learning, or why are we studying mathematics for machine learning. That is one reason. Now next, let's see a few more points about few more concepts. Sometimes the data set which is given to us is not perfect. It has noise. Noise means maybe student marks, maximum marks of student for course. This is marks column. I should have 100 maximum as the marks. Sometimes I have -3, sometimes I have 0, sometimes I have 120. This is invalid. This is invalid. 97, 83, 60, 73, 64, all these are valid. But if you have the marks as -3, if you have the marks as 120, incorrect. So we have noisy data in that. Noise means erroneous data, data which is not in proper format or which is not as per the rules. So when you have such noisy data, with that data set which has noise, you are building an ML model. Is this ML model accurate now? No, because the data set is not perfect. It is not accurate data. To form a best ML model, you need to have a better data. You should have the best data with you. Now, data science is nothing but converting a given data set to a best data set. That is my definition. You apply lot of techniques there. You do lot of operations there on the given data set. So I would say data set, then comes data science, then comes your ML model. Then you do your business, that is prediction or classification. Okay, so when you have data set with you, you have to apply, you have to do data science there. You have to apply lot of data science concepts to make it a perfect data. Then on that perfect data, you apply the ML model. You apply the ML model. You will get a nice model which will do accurate predictions, best classifications. You can do our business with that. But can we always apply data science? Can we always convert given data set into perfect? No. No data set can be converted to 100% pure and perfect data set. We cannot. There are a lot of challenges with the data. Though data science exists with limited knowledge, still you cannot form a best data to form a ML model. So we have to believe that it is a fact that sometimes always there is noisy observations exist in the data set. Now, maybe you can reduce the percentage. See, 80% accurate data you had, you applied data science concepts, you might convert into 98, but not 100. By applying data science concepts, you might convert that particular noisy data set from 80 to 98, but not 100. So it's always believed that there exists noisy data. Now, when you form such model with this noisy data, there is some sort of uncertainty. What is this uncertainty? Little simple example. You formed a ML model M1, which is used for maybe again I will talk a little about regression here, which is used for predicting the bike cost. Honda Activa is one bike. We had 3G, 4G, 5G, 6G. A lot of versions are coming. I have this historical data. I want to find out, predict what could be the price of the next ML model. Okay, so I have that data with me. I form the ML model. It is doing prediction. It is doing prediction. But was the data accurate? No, it had little 0.15% noisy was there in that. So it is predicting and saying that the future price could be 1.65 lakhs. It is predicting. But is it true? It might not be. It can be lesser than or greater than. It can be greater than or less than 1.65. Now, when I formed an ML model with some uncertain data with me, whatever prediction I have made, I am not confident about this. I am not 100% confident that 1.65 lakhs can be the future price of the next version of the Honda Activa bike. I am not confident. Why I am not confident? Because the model which I have formed, right, is not perfect. Why it is not perfect? Because the data which I have used is not clear. Okay, but still, when we form a machine learning model, we give some probability. We say that 98% I am sure that this 1.65 can be the future price. I can tell this right in some scores. This is confidence. We say confidence interval here. We'll see that in statistics. So this 1.65 lakh price which is predicted by this ML model, I will say I am 95% confidence that this is true. Or I can say the ML model which I have formed, M1, okay, this is 95% true, perfect model. I can say the accuracy of the model is 98%. So uncertainty exists in the model. That's why we study about probability theory. We study about probability theory. Okay, because how do you quantify the uncertainty? Using probability. Okay, so next, that's why we also need to study probability in machine learning, because you're forming the data with noisy, there exists a lot of uncertainty. So you have to give some probabilistic measure saying that the ML model is this much accurate. Okay, next, gradient. Okay, I have formed the ML model. I have formed this ML model, mx plus c or y equal to 10x plus 0.72. I formed a regression model. Again, I'm jumping into machine learning. I'm taking about regression as an example. This is a simple linear regression model, 10x plus 0.72. Right. This 10 and 0.72, I have found it out. We are going to find that 10 and 0.72. How? By using existing data. Okay, but how the technique, the approach which we are using to find out this 10 and 0.72 might not be true always. Maybe they are not accurate. The technique which I have used is not accurate, or this 10 and 0.72 are failing always. Okay, this 10x plus 0.72 is used to predict the salary, the cost of the Honda Activa version which is going to come next year. Okay, so this x is the base price. Maybe x is the base price always. Okay, so this x can be somewhere around 3.5 or maybe 13.5 is the base price. Okay, so x can be 13.5 fixed value. So this 10 and 0.72 are variables. When I form a simple linear regression model, the parameters which are in that model, M and C, which I have formed using the historical data, might not be perfect. We have to optimize them. We have to optimize them so that we get a something like this. This 10x plus 0.72 might become 10.3x plus 1.132. It might change like this. See, 10x plus 0.72 has changed to 10.3x plus 1.132. Maybe now, after converting this into this format, it is performing better. It is giving better accuracy or better results to me. It is doing perfect prediction. I told you, 1.65 lakhs is a prediction. Maybe this was giving 1.65 lakhs. This model might give you 1.47 lakhs. And really, when the company Honda Activa released that model, the price was 1.848 lakhs. So see, this is more near to that compared to this. So we have to optimize. Optimization is not a new technique. Optimization is done. So we do optimization there by using gradient. What is a gradient? Derivatives. I'll talk about little about school mathematics. You know about maximization and minimization of a function. You have a function f of x equal to x square. You find out first derivative, then you find out double derivative. If it is less than 0, it is minimum. If it is greater than 0, it is maximum. Minima and maximum points. We use this in mathematics. Right? So gradient is nothing but derivative. Another term given for derivative, or to be specific, partial derivative. Okay, so to study about derivative, partial derivatives, why I need derivatives, partial derivatives? Because I have to, when I am using optimization, we use derivatives there. We use partial derivatives there in optimization. Why I am using optimization? To form a better machine learning model. To form a better machine learning model, we are doing optimization. So the concepts of gradients are discussed in vector calculus. So this is also one separate branch of mathematics which we have to study or which we are studying in the course of machine learning. That's what I was talking about, optimizations, right? Machine learning models are generally represented as mathematical functions like this. F of x equal to 10.3x plus 0.72. This is simple. Maybe I have a multiple regression, 10.3x1 plus 2.7x2 minus 3.4. This is another multiple in regression model. Or I may have a polynomial regression model, 10x square plus 3x minus 7. I may have a polynomial regression model. So all these three are different regression models. We will see that in machine learning. So when we have these, I have to maximize or minimize them, these functions. So for that, I talk about optimizations. So maybe in calculus, you might have studied in your schooling about maxima and minima of a function. So it's a functions concept. So that also we are going to study here. Again, ultimately, statistics comes here picture. When you have large data with you, when you have huge data set with you, to derive some insights from that data, you need to know statistics, because statistics is a special branch of mathematics which provides us lot of tools and techniques. Like simple example, mean, median, mode, quartile, kurtosis, lot of concepts exist in statistics which are helpful for us to derive some patterns from the data, to derive some insight from the data. Okay, maybe statistics is also used in hidden values, for missing values. Suppose you are having a data set. I'll just go back here to get a plain slide. You have a data set with you. You have points like this, some scores, or some maybe ones and zeros, or some category. Like this, you have different features, F1, F2, F3, F4, F5. Okay, sometimes here this is score. Maybe this is the percentage of the student, 89, 73. Here it is 0. Here it is 13, and maybe not 13, 43 or 62. If you see, student has attended the exam, but his percentage is 0. Or sometimes this 0, instead of 0, it is empty like this. There is no value for that. Or sometimes some null exists in that. We don't know this value. To fill these missing values, we need to know the concepts of statistics. So statistics is mostly used in data science. Okay, so data science is all about not cleaning data. It is called cleansing data. Cleansing data. We are not cleaning anything. Cleansing means we are just modifying the data, bringing into proper structure. Okay, so these are few concepts which we are going to use. I hope now you understood why matrices, linear algebra is required in machine learning, while probability is required in machine learning, why statistics is required in data science, why vector calculus is required, and also why matrix decomposition, analytical geometry. All these concepts are directly linked with data. That's why in machine learning, when we deal with data, we study these concepts. I hope you got a rough idea about why mathematics is required for machine learning and why it is important to study the mathematical concepts for machine learning. Okay, so in the next session, after a short break, we'll try to see the introduction to different machine learning terms in simple language. Okay, let's have a